so for number 1 is we have evaluate limits as x approaches 0 sine cube x over sine x minus tan x. So to solve this problem, we can use L'Hopital's rule or Taylor series expansion. So for this problem, we will going to use Taylor series expansion around x is equal to 0. So to recall the Taylor series expansion around x is equal to 0, we have sine x is equal to x negative x cubed over 3 factorial plus x to the power of 5th over 5 factorial. Negative tan x is equal to x plus x cubed over 3 plus 2x to the power of 5th over 15 positive. So therefore, if we simplify this, we will be having sine cube x is equal to this x minus x cube over 6 plus 0 x to the power of 5th 3 exponent equal to x cube negative x to the power of 5th over 2 plus 0 and x to the power of 7. And then we're going to simplify this, and we will be having this and then after that is we will be substituting the Taylor expansions into the limit expressions. So if we're going to do that, we'll be having lim x approaches 0 sine cube x over sine x minus tan x is equal to limit x as x approaches 0 is equal to x 0 x cubed minus x to the power of 5th over 2 plus 0 x to the power of 7 over negative x cubed over 2 plus 0 x to the power of 5th. And then we can divide both the numerator and the denominator by x cubed. So if you do that, we will be having this lim as x approaches 0 1 negative x squared over 2 plus 0 x to the power of 4 over negative 1 over 2 plus 0 x squared. And then so as x approaches 0, the terms with x squared and higher powers approach 0. Therefore, the limit simplifies to limits as x approaches 0, 1 minus x squared over 2 plus 0 x to the power of 4 over negative 1 over 2 plus 0 x of x squared is equal to 1 over negative 1 over 2, so is equal to 1 over negative 1 over 2. So 1 over negative 1 over 2 is equal to negative 2. So the final answer is negative 2. Okay, so for number 2, the problem is using the definition of derivative. Find the function of x of y over y is equal to tan x. So that is, first is the definition of the derivative is function of x is equal to limit h as h approaches 0, function of x plus h minus function of x over h. So for function of x equal tan x, we have that. And then after that is we're going to substitute into the definition. So it will be f function of x is equal to limit as h approaches 0, tan x plus h minus tan x over h. So after that is we will use the tangent addition formula. So to recall the trigonometric identity, we have tan a plus b is equal to tan a plus b over 1 minus tan a tan b, and then applying that to tan x plus h, and then we will be having tan x plus h is equal to tan x plus tan h over 1 minus tan x tan h. So after that is we're going to substitute this into the derivative definition. So we'll be having f function of x is equal to limit as h approaches 0, tan x plus tan h over 1 minus tan x tan h minus tan x over h, and then we will go into simplify the expression. And then after that is to simplify that is we're going to find a common denominator for the numerator, and then after that is we will be simplifying the numerator. And after simplifying the numerator is we will be factoring out the tan h, and for the last is we will be use the known limit. So to evaluate the limit as h approaches 0, tan h approaches 0, we have a function of x is equal to 1 times 1 plus tan squared x over 1 minus 0 is equal to 1 plus tan squared x. So 1 plus tan squared x is equal to secant squared x. So the final answer is secant squared x. Okay, so for number 4, the problem is find the derivative of x cubed plus 4x plus 4 squared times 2x cubed minus x squared exponent of 3. So for this is we will use the product rule and the chain rule. So for the first is we will be using chain rule. It's like let ux is equal to x cubed plus 4x plus 4 squared, and the vx is, so the vx, our vx is 2x cubed minus x squared exponent of 3. So if we're going to solve that is we will be I mean to use to find the derivative of that is we will be using chain rule. So which is this u x is equal to 2x 2 is x cubed plus 4x plus 4 3x squared plus 4, and the v of x is equal to 2x cubed minus x squared exponent of 2 and the exponent of 2 6x squared minus 2x. And then after that is we will be applying the product rule. So the product rule states that the derivative of a product of two functions is uv is equal to uv plus uv. So apply that to our function, and then we will be substitute and simplify, and then the answer is this. The final answer is 6x plus 4 1 plus x cubed plus 2x squared exponent of 2 minus 3x squared plus 4x 6x to the power of 5 plus 20 to the power of 4 plus 16 cubed over 1 plus x cubed plus 2x squared in the exponent of 2. Okay, for the number 4, the problem is find the second derivative of y is equal to inverse tangent function x cubed plus 2x squared. So we have let y is equal to arctan x cubed plus 2x squared. So to find the first derivative is we can use the chain rule. So using that is we will be having dy over dx equal d over dx arctan u is equal to u prime over 1 plus u squared, where u is equal to x cubed plus 2x squared. So the u prime is equal to 3x squared plus 4x, and I will be having dy over dx is equal to 3x squared plus 4x over 1 plus x cubed plus 2x squared, the exponent of 2. Okay, so to find the second derivative is we'll be applying the quotient rule. So we have this as the right in the paper, and after applying that is we will be calculating the derivatives in the numerator separately. So we have d over dx 3x squared plus 4x equal to 6x4, and then the result is after that the final answer is on the paper.